In this video, I'm going to talk about simplifying square roots. When I'm simplifying square roots, I want to take out the things inside that are perfect squares or things raised to the second power, because if I take the square root of something raised to the second power, it's going to be a whole number. I can write that whole number on the outside of the square root. I don't have to keep it inside of the square root. Perfect squares, if you forget what they are, I have 1 squared is 1, 1 is a perfect square. I have 2 squared is 4, 4 is a perfect square. I have 3 squared is 9, 9 is a perfect square, and so on. If I have 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, whoops, that's 9. Forgetting how to count, 9 squared and 10 squared. And 4 squared is 16, that's a perfect square. 5 squared is 25, that's a perfect square. 6 squared, 36, that's a perfect square. 49 is a perfect square. 64 is a perfect square. 81 is a perfect square, and 100 is a perfect square, and so on. 11 squared, 12 squared, 13 squared, etc. So when I want to simplify the square root of 24, I want to take out the biggest perfect square inside of 24. That's a factor of 24. So what I'm going to look at in this list that I just made, because those are all the perfect squares in order from least to from the smallest one going up. It's not all the perfect squares, but what I want to look for is all the perfect squares that are less than 24. So 25 wouldn't work, so I'm looking at 16. Does 16 fit into 24? No. Does 9 fit into 24? No. Does 4 fit into 24? Yes. So 4 would be the biggest perfect square that I can break this down into. So I have 24 breaks down into 4 times 6. So this is really the square root of 4 times 6, which I can break down into the square root of 4 times the square root of 6. And the reason why I can do that is, if we go back to our exponent rules, if I had 24, the square root of 24 is actually 24 raised to the 1/2 power, to that fraction 1/2 power. That's the same thing as taking the square root of 24. My exponent rule says, okay, if I break down 24 into 4 times 6 and have that raised to the 1/2 power, which I can do, because 24 is in parentheses there, so I could break it down into 4 times 6. I know that I can rewrite this as 4 to the 1/2 power times 6 to the 1/2 power, because I can distribute that 1/2 power. That's the same thing I did here. So this is 4 to the 1/2 power. This is 6 to the 1/2 power. Now that I have this broken down, the square root of 4, I know I can rewrite as 2. So I have 2 times the square root of 6. The square root of 6 can't break down any further. There's no perfect square factors inside of there. 4 is not a factor of 6. So I leave it like that. There's nothing squared inside. 2 times the square root of 6 is that simplified square root. The square root of 50, I'm looking for the biggest perfect square. And what? Oh, whoops. I'm looking for the biggest perfect square inside of 50. Well, 49 doesn't work. Come on. 49 doesn't work. 36 doesn't work. Oh, 25 is a factor. So I'm going to break this down into the square root of 20. Well, I'm going to write it 25 times 2. That is the square root of 50 broken down. Square root of 25 times the square root of 2. I can rewrite this as the square root of 25 times the square root of 2. That is 5 square roots of 2. And that's my simplified answer. For the square root of 500, I don't have a list that goes above 100, but I just know that the biggest perfect square inside of 500 is 100. So I break this down into 100 times 5, the square root of that. This is the square root of 100 times the square root of 5. That's 10 square roots of 5 is my simplified answer.